for being a wonderful audience yesterday, and you have heard about applications of soft computing technique yesterday delivered by our resource person, Dr. S.R. Tandon sir. So now I'm going to start with the second day of this 3 days online national level webinar. Uh, Good morning, respected principal sir, all faculty members, my dear students from various colleges and other universities. Uh, for this 3 days online national webinar on current and emerging trends in computer technology, which is the need of current scenario in IT industry, organized by our Department of Computer Science and Application. Thank you all for being the wonderful audience for yesterday. Hope you have been enlightened and benefited with yesterday's topic of application of soft computing. And with same enthusiasm, you have joined us all today. In the same sequence, we are continuing with our schedule as mentioned in the brochure. It has been said in the technology field, the only constant in technology industry is change. The technology we learn today is gets old by a day. So as the need of industry changes, we need to upgrade ourselves. And that's the motto of our this online national webinar. We are conducting this webinar to we want our participants to get enriched with today's technologies and current trends which are running in the market industries out of the curriculum syllabus which you read out and the industries of today era, the demanding technology. So that's why we have conducted this 3 days online national webinar. And in the same sequence, we are continuing with our schedule. Uh, Today we have our resource person as Dr. Girdhar Urkude, assistant from KL University, Telangana State. I really feel privileged and honored to have him with us as he is also a batchmate of mine, PG 2009. We have done PG from the same college in 2009. So I really feel privileged and honored to have him with us, Dr. Girdhar Urkure, sir. Firstly, I would like to welcome on behalf of college to our resource person, Dr. Girdhar Urkure, sir, for sharing us his valuable knowledge with us. I extend my heartfelt thank to Dr. Girdhar Urkure, sir, once again. Now, I would like to give a brief about Dr. Girdhar Urkure, sir. Is Institute of Technology Computer Application from CSVTU Bhilai. He was an assistant professor at Sri Shankaracharya Mahavidyalaya Bhilai for about 1 year. He served as a lecturer at NIT Raipur for over 6 years. Right Hyderabad, he published research articles in international journals, among which
सर आवाज नहीं आ रही है आपकी। केबल
is
लाइन केबल नहीं, वो है टेबलेट है।
centered on IoT-based domain, but today's session based topic on shared sir.
सर बोलिए,
Am
आवाज
I
आ रही है।
audible? Dr. Kashyap Rathore, sir. Am I audible?
I am requesting Dr. Girdhar Urkure sir to proceed over the session.
यस सर,
Sir, your voice is audible now. Yes, sir, your voice is audible now.
So, the respected principal, sir, Government Digvijay Autonomous PG College, Rajnandgaon,
Now I
all the
request you to
respected, all the respected faculty members of the uh, Digvijay Autonomous PG College, and dear students. So, I would like to thank you at first for this lovely introduction and the thing actually said by Rathore sir. Now I'm going to present my PPT. Is it visible? Let me know, please. Is it visible? Rathore sir, is it visible? PPT is visible?
Yes, sir.
And my voice is audible, students?
Yes, sir.
Okay.
yes sir.
So thank you for this warm welcome, and I'm actually honored to have you all. So today I'm going to present a presentation on the Internet of Things as well as the semantic web technology, and how can we achieve the collaboration of Internet of Things as well as the semantic web technologies together. So we will see these two things in our session, how and how can we merge these two things. So, in our presentation, the outline will be like this. First of all, we will see the introduction part where I will discuss about the Internet of Things, what are the Internet of Things data, and the different type of technologies that actually make the IoT, that is the IoT vision. And after that, we will see the hardware and software part of the Internet of Things that actually required in order to make the some nodes or some real-time sensing devices. And after that, we will see using this hardware, how can we actually establish a WSN, wireless sensor network, in order to create one IoT type of architecture. And after that, we will see the IoT architecture itself, and after that, the semantic web. And how can we make this semantic web happens with the this collaboration with the
सर वॉइस नहीं आ रही है।
um, my voice is audible or not?
Yes, sir. Audible.
Sir, it is audible.
Yes, sir.
Audible. It is audible. Audible.
For some student, it is not audible, I think. So maybe
Ah,
some technical issues. Okay.
might be network error at her end, sir. Your voice is
So,
audible at this end.
okay.
Okay.
So we'll go forward. Then the semantic web, and how can we collaborate the semantic web with the IoT? And using the IoT data, how can we model the IoT data using semantic web? We will see this. So I will cover mainly the IoT and the semantic web, or we can say the semantic web of things generally in this session. So at first, Internet of Things. So what is the Internet of Things? Internet of Things is the interconnection of various kind of devices, various kind of physical things. It is also known as the ICOs, means the Internet Connected Object. That means the object that are connected with the different kind of sensors, and it is exposed to the internet. So that actually data we can send to the other nodes or other servers. And these ICOs, the Internet Connected Object, sense the environment due to the sensors are attached to it, and generate the data. And after processing the data, we actually get the knowledge. The knowledge acquisition can be done from these devices. So because of the ICOs or internet connected objects that are actually part of the Internet of Things are so many. It is very huge. It is actually spread in each and every domain. Like you can see here in the picture, smart home, smart taxi, smart cities, or smart agriculture, smart business, whatever you can see, all the domain actually interrelated with the Internet of Things. So many devices are actually spreaded on these domains, and after getting the data, there are enormous amount of data. There are huge amount of data that we are actually getting from the IoT ecosystem. So this data actually sending from one node to another, and likewise those nodes are processing those data in order to get the real-time activities. So vision of the Internet of Things is like this, means any data or anything is connected with the anything at any time and any place for everyone, makes the Internet of Things. That means it is a ubiquitous system, it is pervasive system, it exists everywhere. Here you can see it is this chart. This figure is actually borrowed from the Cisco, and it is predicted by the Cisco that by 2023 there will be 50% of devices. The whole devices are say 100%. Then there will be 50% devices are M2M. M2M devices means machine-to-machine communication devices, and these are ICOs, internet connected objects, or we can say the devices that are responsible in order to achieve the Internet of Things. So the Internet of Things devices will be 50% or more than 50%, and the rest of devices are there also. But the most of all devices are M2M devices. So it is predicted by this system. And because of, I have told you earlier, we are getting a huge amount of data, an enormous amount of data. And each and every data item is important. Why? Because of we need to know the real-time processing. If say one data is missing and some critical thing is there in on that data, we cannot recognize what is the critical thing was. So each and every data item is important. Okay, we need everything, every data. And it is estimated that the 90% of today's data are actually generated in past 2 years. That means अभी का 90% डेटा लास्ट 2 years में जनरेट हो गया है, एंड 2.5 quintillion bytes of data is created every day. Means 2.5 quintillion bytes of data means 10 to the power 24. 10 to the power 24 bytes are data actually generated every day. So it is very huge data. Even it is estimated that at the early 2020, 44 zettabyte of data has been created. And it is actually due to M2M connection devices, machine-to-machine communication devices, or we can say the Internet of Things devices. And these devices are fastest growing devices. Everywhere we can see in the fridge or ACs or fans, there are M2M devices that are connected with the other systems as well as that are connected with the internet. So these are the IoT devices that generates an enormous amount of data. And here we can see say one node or smart device is there, which actually generate the raw data. Then this data is at the same time it should be machine interpretable. That means if I'm sending this data to some machine, so machine can interpret this data, as well as this data should be human understandable. That means by seeing this data, by looking this data, we must able to understand that what is this data all about. And at last, this data must be interoperable. That means if one system is sending this data to another system or any other system, more than two systems can be there, then those systems able to interoperate, or those systems are able to see this data as their own data. That means they can interoperate with each other using this data. So at the same time, we need machine interpretable, human understandable, and interoperable data if some devices are generating the data. So because of IoT devices are everywhere and data are very huge. So the data challenges are very huge, and some IoT data challenges are like this. IoT data are multimodal and heterogeneous. That means it is multimedia data, means the different type of data, as well as it is different in qualities. It is heterogeneous. It is coming from the various type of devices like fridge or a fan or AC or some machines. So heterogeneous type of data is there. Sometimes it is noisy and incomplete. Sometimes what happens because of it is nothing but the IoT devices. Maybe it fails and then it actually generates some noisy as well as not the completed data. So it can be noisy and incomplete. It is time and location dependent because of sensors are attached with it. It is time and location dependent. It dynamics and varies in quality. Like we can see in the YouTube, if we wanted to see one video, the video can be of 144 pixels. Otherwise, that same video can be of 1080 pixels. So the same video is of two varieties. So the data, the IoT data is like this, like that only, and it actually varies in quality also. So the same data can be in different varieties. And the crowdsourced data is unreliable, so we cannot rely on the crowdsourced data because of we don't know the source. If we don't know where the data is coming from, we cannot rely it. It can be malicious data, it can be some spam. So crowdsourced data is not reliable, as well as because of these are the IoT data. It is coming from the sensor devices. It needs real-time analysis. It needs some real-time processing in order to get the result. So ultimately, we can say we need to know our data. We must know our data. What is our data is all about. And data is not sufficient. If I'm giving some data to you people, like I'm telling you, I'm giving you some 36 or 37. What is 36 and 37? If I'm telling you the 37 degrees Celsius temperature of my room, then it is significant. So people don't want data. They don't want data actually. They want answers. Means if I'm giving some data, they will not able to understand. If I'm giving some answers or some cognition kind of things, yes, they will accept it. So they want answers. And for that, we need to process our data, the IoT data. Here, we can see the knowledge pyramid that actually made from layer by layer. We can say that there are several layers in order to get this knowledge pyramid. The bottom of this pyramid actually is the raw data that are actually acquired from the different kind of devices, different type of sensors or actuator. And after getting this raw data, if we are applying some semantics, we are applying some data formation, then we'll get this structured data. Think this as HTML programming means what we are doing, we are actually formatting this data. Okay, we are actually adding some things. We are adding some meaning to the data. And after getting the structured data, if we extract the knowledge from this data using the cognition power as well as abstraction, we get the information part, that is the knowledge. And if we apply this information, this knowledge to somewhere else, in some scenario or some domain, we will get the wisdom. Wisdom means the applicable knowledge only. So, in order to get the wisdom, we need to process our raw data in this particular manner, in this pyramidal manner. And the IoT visions. So basically, IoT is not the technology itself, but it is the combination, or we can say the convergence of different kind of technologies. Means different kind of technology merge together and make the Internet of Things. So there are some visions like internet-oriented vision, thing-oriented vision, semantic-oriented visions. So these visions actually make the Internet of Things. The internet-oriented vision consists of lots of things like Internet Zero, IP address for small objects, Web of Things, um, the World Wide Web, and etc. The thing-oriented vision actually associated with the things or tangible parts. We can say hardware, like building the WSN, RFID, that QR code, everyday objects, spines, NFC, Bluetooth. These are thing-oriented vision, which are actually related with the protocols as well as the hardware parts. And then the semantic oriented vision. The semantic oriented vision is nothing but if we are getting the data from the sensors using the internet, means getting the data means thing oriented vision actually deals with the hardware part as well as the protocol part. And after getting the data from this hardware, if you are exposing this data to the internet using the internet oriented vision, and we are applying some semantics to this data, it becomes semantic oriented visions. That means we are giving, we are applying some semantics, we are giving some meaning to these data using semantic web technologies. So semantic web technologies is there, reasoning is there, some different type of semantic web technologies like RDF, RDFS, all is there. So we'll talk about the semantic web of things or semantic oriented vision at last, means after the completion of the IoT part. So basically, the convergence of different kind of visions make the internet Internet of Things. So first of all, I will tell you about the Internet of Things. What is the Internet of Things, and how can we create one kind of hardware in order to deploy this hardware to get some data, and how can we expose this data to internet in order to get the Internet of Things, means hardware part as well as software parts, or we can say the data part. So I think it is clear by now. And, so we will go for the hardware and software part. So here we can see, I think lots of people, lots of students know about this thing, Arduino Uno. Arduino Uno is very small kind of device, which is also called as microcontroller. And it has some pins that actually can connect with the sensors and that actually sense the environment. And using this Arduino, we can collect the sensors data, and we can send this data to the outer world, or we can send this data to some WSN kind of things. So हम यहाँ पर आप देख सकते हो, यहाँ pins है like 3, 5, 6, 9. These are the pins, power pins. हमें जंपर वायर के थ्रू, हमें वायर्स होते हैं कुछ, उसके थ्रू हमें सेंसर्स को कनेक्ट करना है इसमें, और हम इसमें प्रोग्रामिंग करते हैं यूजिंग सी, strictly C or C++. So if I will upload the program, those actually getting the data from the sensors, if we upload this program, this device can means extract the data from the sensors. So it is specifically Arduino Uno. There are several kind of devices that are microcontrollers also. We can use those also, but this is the most means useful device, or we can say usable device. So Arduino Uno is very particularly, we can say, it is common device. And then how can we actually program this Arduino Uno? So there is one Arduino Uno software which is called Arduino software, Arduino IDE, and using this IDE we can program this Arduino Uno. And here we can see there are two methods, or we can say two functions. One is setup, and second one is the loop. So setup is nothing but means declaring all the uh, environmental variables, all the variables which are necessary. And the loop is, if say we are connecting some temperature sensor to the Arduino Uno, then we want this temperature data means cyclically. That means for in every 1 hour or in every 5 minutes. So loop actually is the function where we can put the code that actually get the data in continuous manner, in a periodic manner. So it is the software in order to upload this sketch, or we can say upload the program to the Arduino Uno. Here, I'm actually showing you some other kind of hardware, which is Raspberry Pi 3 Model B. So it is actually the family of Raspberry Pi devices, and this particular device is actually microprocessor device. It is not the microcontroller, but the microprocessor. And I think you know the difference between the microcontroller device and the microprocessor device. Okay, let me tell you. So microcontroller devices are limited in capabilities. Like it means it is having some flash memory in order to upload this sketch, but it is not having some great computational power as well as some other memories to store the data. But uh, in a different way, the microprocessor actually having all those things which are required in order to upload the operating system. That means all the hardware like HDD, hard disks, RAM, random access memory, USBs, HDMI, all these things. That means it is actually rich in computational power. But at the same time, the Raspberry Pi or some microprocessors are not actually that much cost effective. These devices are costly as compared to microcontrollers. We can get our microcontrollers, that means Arduino Uno, by this 500 to 600 bucks. But if we wanted to buy Raspberry Pi 3 Model B, or wanted it, there is some new device is there. It's the Raspberry Pi. It is Raspberry Pi 4, I think. So in order to get that device, we need to spend uh, near about 4 to 5,000 rupees. So it is quite costly. And if you wanted to make the WSN, we cannot use this device everywhere because of it is kind of costly. If we wanted to make some 100 nodes, we cannot use this type of devices. That's why we are actually taking the combination of Raspberry Pi as well as the Arduino Uno. Okay, here we can see one temperature sensor. It is specifically DTH11 temperature sensor. It is having 3 pins, and these pins actually can connect with the Arduino Uno as well as the Raspberry Pi. But in my scenario, what I have taken is I have actually created one WSN and attached this temperature sensor specifically to the Arduino Uno, because of it is cheap kind of device. So because of I need, if we need several devices, lots of devices, so it is better to have Arduino Uno. So here we can see This DTH11 sensor is actually connected with the Arduino Uno. Okay, so there are three pins, and these are the jumper wires. You can see the blue type of wire, red type of wires, and black type of wire. And these wires are actually attached with the DTH11 sensor. Okay, and you can find the data sheet for the DTH11, and you can find all the things. How can we connect this DTH11 to the Arduino Uno? It is very easy. It is very easy, and you can get the program also from the internet. So it is a, I think, half an hour task. If you are having all the hardwares, it will not take more than 1 hour to upload the sketch as well as to get the data from the DTH11 temperature sensor. So it is quite easy. And here I'm showing you one more sensor device. It is nothing but the SCSR4 ultrasonic sensor. So mainly this sensor is useful to get, means to know the distance of the obstacle. One part is actually known as the trig, and second part is known as the echo. So trigger actually generate the sound waves in form of the radio wave, and that echo part actually receive these sound waves after means when this trigger means this radio waves actually means goes to some obstacle and revert back, then echo captures this kind of uh, radio waves, and it actually will get the distance. Here we can see the ultrasonic sensor is actually can be also attached with the Arduino Uno as well as the Raspberry Pi. Because of the Raspberry Pi is a bit costly, that's why we can use the Arduino Uno. And here there are 4 pins, and we can attach this 4 pin to the Arduino Uno. And you can find this connection in the data sheet also. It is very easy, as well as you can find this data connection from the internet, as well as you can find the program also. So using the ultrasonic sensor, we can find the distance. Here I'm showing you one special kind of devices called XBS2C, which is which is actually created by the DG International. And this device is actually is useful in order to create the WSN. So these are the devices send the data from one node to another node wirelessly using the radio communication. And there are so many type of devices that actually can be used for the wireless communication, like Wi-Fi devices, like Bluetooth devices. There are SPIMEs also, LoRa devices are there. But the main thing of the XBs are this, that it actually follows Zigbee protocol, and it is a standardized protocol given by the IEEE standardization. So it is one standard device that actually follows IEEE rules. So that's why you can use this type of devices. It is a bit costly. It is we can buy this kind of devices from the $900. So it is a bit costly. But in order to create WSL, these are the devices which are very reliable. And here in the right side, we can see the shield, the blue one is shield. This shield actually can be attached on the Arduino Uno, and after attaching this shield, we can attach this XB on the top of this Arduino Uno. Here we can see, here I'm showing you the whole setup for the WSN node, or we can say wireless sensor node, wireless sensor network node. It is one Arduino Uno. On the top of Arduino Uno, shield is attached. On the top of the shield, we can see XBS2C is there, which is actually helpful in order to send the data wirelessly. And Also, the Arduino Uno connected with some type of sensors. Here, I have taken soil moisture sensor and DTH11 temperature sensor. So you can take any kind of sensors, but it must be compatible with the Arduino Uno. So here you can take any type of sensors and you can send this data. You can send this data to the other nodes as well as the internet. Here you can see I have used in our experiment, I have used one Raspberry Pi. It is Raspberry Pi 3 Model B that we have seen in the earlier slide. And it is also attached with the XP. It is one kind of XB USB connector, and it actually using for the attachment of the XPs. Okay, so if some wireless sensor network nodes are sending the data, and then this device, the XP device that I have actually seen all the hardware parts earlier, like Arduino Uno and Raspberry Pi and XPs. So using all three type of devices as well as the sensor are attached with the say Arduino Uno, this kind of devices actually can make the wireless sensor network. Using the XBs, these devices can send the data to the coordinator. We can say the Raspberry Pi. So basically, in the WSN, there are three type of devices. One is end sensor node, second one is the router, and third one is the coordinator. Three type of nodes. So end sensor node's responsibility is it actually take the data from the environment. It sends the data from the environment and send the data to the coordinator. What is the responsibility of the router? Say I'm actually establishing one WSN, and this WSN having the one device in sensor node is very far away from the coordinator. It is not in the range. That means हमारा जो कोऑर्डिनेटर है या रास्पबेरी पाई है वो इतना दूर है इन सेंसर नोड से कि वो कम्युनिकेट नहीं कर सकता, रेंज के बाहर है. देन ये इन सेंसर नोड क्या करेगा? व्हाट इट एक्चुअली इट विल डू, इट सेंड द डेटा टू द राउटर. समझ लीजिए राउटर इसके बीच में है. देन ये जो इन सेंसर नोड है ये हमें डेटा राउटर को भेजता है एंड राउटर दूसरे राउटर को भेजेगा, और जो राउटर सबसे पास में होगा रास्पबेरी पाई के, वो उसे डायरेक्टली रास्पबेरी पाई में भेजेगा. दैट मीन्स इट इज नथिंग बट द होप्स इन बिटवीन द इन सेंसर नोड एंड द रास्पबेरी पाई. एंड if data is not directly being sent, then it is sending using the routers, or we can say hopes. And the third one is the coordinator. So we have actually chosen this Raspberry Pi, ये जो माइक्रो कंट्रोलर है जिसकी कैपेबिलिटी कंप्यूटेशन कैपेबिलिटी ज़्यादा होती है. We have chosen this device as the coordinator. Why? Because of the coordinator's responsibility is to establish the WSN, establish all the nodes, to route how means to establish what are the devices those are responsible for the routers, which are the devices those are responsible the in sensor node. So it is managing all the things. It is managing all the parts, as well as it is storing the data that are actually captured from the router as well as the internet. From the routers and in sensor node. So that's why it should be greater in the capabilities, means storing capabilities as well as the computational capabilities. Okay, so using this type of hardware we can make our WSN. And हम WSN की बात क्यों कर रहे हैं? Why we are actually interested in WSN? Because of in order to establish the Internet of Things devices, or to set up the Internet of Things architecture, we need WSN. हम डेटा कैसे कलेक्ट करेंगे, हम डेटा कैसे भेजेंगे, ये हम WSN के थ्रू ही बता सकते हैं. Okay, so we need one WSN in order to establish, in order to get the IoT architecture, or in order to make one device as the IoT device. Here we can see the overall architecture of the Internet of Things. So I have told you earlier, the Internet of Things is nothing special kind of technology, but it is the combination of technology. Different kind of technology actually merging together and it is actually becoming IoT, Internet of Things. So ये स्पेशल कुछ नहीं है कि हम IoT में कोई टेक्नोलॉजी देखेंगे, ये मर्ज है डिफरेंट काइंड ऑफ टेक्नोलॉजी का, और हम यहाँ देख रहे हैं कि डिफरेंट टाइप ऑफ हार्डवेयर, WSN, क्लाउड टेक्नोलॉजी मिलकर सब साथ में मिलकर आईओटी बनाता है. Okay, so this is nothing but one IoT architecture. In this architecture, I have divided uh, this architecture in two layers. One is device level layer, and second one is the network level layer. So first of all, we will see the device level layer. So हम वैसे पहले भी देख चुके हैं कि कौन कौन सी डिवाइसेस है जो कि यूजफुल है इन ऑर्डर टू क्रिएट द WSN. Okay, so like Raspberry Pi, Arduino Uno, sensors, XPs, these are the devices which are responsible to make the WSN. Okay, and the Arduino Uno or some microcontrollers are attached with the sensors, and this send the data to the coordinator, and we can make our WSN using the mesh topology or different type of topologies. There are so many topologies, but it is better to have the mesh topology so that we can send the data indirectly. That I have told you earlier कि अगर कोई डिवाइस बहुत दूर है कोऑर्डिनेटर के, तो वो मल्टीपल होप्स के थ्रू कोऑर्डिनेटर को डेटा भेज सकता है. सो मैश टेक्नोलॉजी मैश टोपोलॉजी होने से हम डेटा को मल्टीपल होप्स के थ्रू भेज सकते हैं. सो मैश टोपोलॉजी इज बेटर, but the complexity is also there. Na? It depends on your scenario, which actually topology you wanted to choose. Okay, so मैंने ये किया था कि I have actually disseminated all these sensors over the agriculture field because of I have taken the domain as the agriculture. Then for that scenario, the mesh topology was the better solution for me. That's why I used mesh topology. और जैसे कि मैंने बोला था कि जो कोऑर्डिनेटर है वो काफ़ी कॉस्टली डिवाइसेस होते हैं और आर्डिनो ऊनो थोड़े सस्ते होते हैं. तो उससे अगर मुझे एक WSN बनाना है और WSN में मेरे पास से 50 डिवाइसेस है, देन ये सभी 50 डिवाइसेस को मैं रास्पबेरी पाई नहीं ले सकता. Why? If one Raspberry Pi's cost is say 4,000 rupees, then 4,000 rupees into 50, that means it is very huge amount. No? If I'm actually taking some Arduino Unos, like one Raspberry Pi and 49 Arduino Unos, okay, 49 Arduino Unos. Say one Arduino Uno comes of 600 rupees. So 49 into 600 rupees plus 4,000 rupees into 1. That means it is a quite compatible solution. हमारी कॉस्ट भी कम हो जाएगी एज वेल एज हमें एफिशिएंट डेटा भी मिल सकता है. ओके, सो कॉम्बिनेशन अक्सर यही किया जाता है कि जो आपके माइक्रो कंट्रोलर्स है उसे इन सेंसर नोड बनाया जाता है एंड द माइक्रो प्रोसेसर इज एक्चुअली यूजिंग एज द coordinator so that it can actually receive the data and send the data to internet. The second thing is the network layer. Network level. Network level architecture, or we can say level. So in the network level, I have used Zigbee protocol. Okay, as well as the internet is involved. So why internet is involved? Say these devices, the coordinator devices, actually capturing the data. It is accessing the data. It is receiving the data, and after receiving the data, what actually we have to do this data? We have to send this data, those data, to the internet in order to further communication. So for that we will use different type of protocols as well as different type of methods. So different type of hardware devices in sensor node devices are actually sending the data to the coordinator using Zigbee protocols. Okay, IEEE standard protocol, and this Raspberry Pi sending those data to the internet using some other protocols like FTP, file transfer protocol. Nowadays, OAP is there, and so many protocols are there. So we can choose any of the software, software part, or we can say the protocol part. So it is the network layer. That means we have connected our WSN to the internet. So I think it is clear. If you are having any doubt, you can interrupt me in between. ना? So सो हमने हार्डवेयर पार्ट भी देखा, हमने ये भी देखा कि कैसे हम सेंसर्स को कनेक्ट कर सकते हैं हार्डवेयर पार्ट से और कैसे एक डेप्लॉयमेंट एस्टैब्लिश कर सकते हैं यूजिंग मैश टोपोलॉजी और एनी अदर टोपोलॉजी. Actually, I cannot read your messages. If you are messaging me, please don't message me. You can interrupt me in between. Just ask me the question if you are having any doubt. Thank you very much. And then after very old also. So we need one data format in order to show the data, in order to arrange the data. Okay, IoT data we can say. And after that, RDF is there. RDF का काम होता है. It is the abbreviation of the RDF means the full form of the RDF is the Resource Description Framework. What is the task of the RDF? It actually provides the semantics. ये meaning देता है data को. It actually provides the semantic to the terms. Okay, कैसे हम आगे देखेंगे. And OWL, it is its full form is Web Ontology Language. For the pronunciation sake, it is written means it is actually means pronounced as OWL. Okay, but its full form starts with W. This it is Web Ontology Language. So RDF is actually limited. RDF and RDFS is limited. It actually not provide all the semantics which is needed. So OWL is the next level semantics. If you wanted to provide this next level semantic, OWL is there. So I will discuss these things. So we have seen that the data format, and simply the data format is not enough. If I'm using some XML data, because of we know that XML actually made up from the tags, different kind of tags, any kind of tag that you can make. Because of हम अपने tags खुद बना सकते हैं. Then मैंने अपना एक XML फाइल बनाई. Likewise एक थर्ड पार्टी यूजर है वो भी अपनी एक XML फाइल बनाता है. Then वो उसके टर्म्स खुद डिफाइन करता है और हम दोनों एक दूसरे को डेटा से भेजते हैं. अब एक दूसरे को डेटा भेजने से प्रॉब्लम ये है we cannot actually understand each other's term because of my data set or sorry my vocabularies are different. मेरे जो टैग्स है वो डिफरेंट है, उनके टैग्स है वो डिफरेंट है. तो ये डेटा आपस में कम्युनिकेट नहीं कर सकते. क्यों? क्योंकि हमने एक ऐसा सिस्टम बनाया जो कि एक ही टाइप के टैग को समझ सकते हैं. तो सिंपली डेटा फॉर्मेट इनफ नहीं है. Okay, the data format is not enough. So what we want? We want some technologies that actually create a common data standards or common vocabularies. So the semantic web actually provides the common vocabularies, and it includes data formats, RDF, RDFS, OWL. So we have seen all these things. Okay, and Sparkle and semantic rules. So what is Sparkle? देखिए हम डेटा को स्मार्ट डेटा बना रहे हैं, हम डेटा में मीनिंग प्रोवाइड कर रहे हैं. इफ वी आर प्रोवाइडिंग द मीनिंग टू द डेटा, सो वी कैन क्वेरी ओवर इट. हम उसमें क्वेरी कर सकते हैं, उस डेटा को प्रोसेस कर सकते हैं. सो स्पार्कल इज अ क्वेरी लैंग्वेज फॉर द सेमेंटिक वेब. यूजिंग द स्पार्कल वी कैन क्वेरी ऑन दोज डेटा as well as the semantic rules. If you wanted to restrict some data, if you wanted to put the limitation on data using the semantic rules, we can do it. Okay, so these are the semantic web technologies. Okay, और ये semantic web technology हम use क्यों करते हैं? So that we can make the simple data as the smart data, and we can apply the semantic web on the IoT also. Okay, we can apply anywhere, but nowadays it is actually a trend that applying semantic web to the IoT data. देखिए अब मैं यहाँ पर एक डेटा मॉडलिंग का कॉन्सेप्ट बता रहा हूँ जो कि सेमेंटिक वेब के थ्रू है एंड इंटरनेट ऑफ थिंग के थ्रू है। सेमेंटिक वेब एंड इंटरनेट ऑफ थिंग दोनों को मिलाकर nowadays it is called as semantic web of things। semantic web of things कैसे ये semantic web of things काम करता है? See here we can see it is simple data, it's the data that are generated by the sensor. Here we can see the temperature is the data is actually shown, humidity data is shown, soil moisture data is shown, and the temperature value is 27, humidity value is 65, and soil moisture value is 35. If I'm means giving you some data like 27, then you cannot know that what is 27 means what this data all about. But if I'm giving the data in this format, then your system can interpret this data, and even by looking this data you can also know what this data is all about। देखिए यहाँ पर आप सीधा बता सकते हैं एक टेम्परेचर सेंसर है, टेम्परेचर सेंसर की अभी रिसेंट वैल्यू 27 है और इस वैल्यू इस टेम्परेचर का यूनिट सेंटीग्रेड है। लाइकवाइज ह्यूमिडिटी 65 है जिसका यूनिट परसेंटेज में है, और सॉइल मॉइस्चर 35 है और इसका यूनिट भी परसेंटेज में है। तो हम यहाँ पर इस डेटा को देखकर इजीली बता सकते हैं कि ये डेटा किस बारे में है। बट सिंपली अगर मैं रॉ डेटा भेजता हूँ 27, 65, 35, then we cannot able to understand this data. So how can we provide the meaning? It is nothing but the meaning. Now we are providing meaning using semantic web. We can provide the meaning, and it is the XML in the XML format. There are so many other formats also, but I'm showing you the simplest format, which is XML. ये भी आप XML का एग्जांपल दे सकते हैं जिसमें मेजरमेंट है एंड मेजरमेंट की जो वैल्यू है वो जो हमारा सेंसर अटैच्ड है किसी इन सेंसर नोड से, तो उसकी वैल्यू है 15, और जो यूनिट है वो डिग्री सेंटीग्रेड है, टाइम है, लॉन्गिट्यूड लैटिट्यूड है उस डिवाइस का। सो इट इज नथिंग बट द डिस्क्रिप्शन ऑफ द that type of device। Okay, so we are providing description, and this description also known as the meaning। Okay, and wait a minute, in the semantic web all the things actually given in form of the triples। triples means 3, triple का मतलब होता है 3, तीन चीजें। ओके तो यहाँ पर हम ट्रिपल के फॉर्मेट में डेटा को रिप्रेजेंट करते हैं। देखिए मेजरमेंट 1 is one triple, then hash value is another triple, and 15 is the another triple। So there are 3 things: measurement 1, hash value 15। ओके और हमने इसमें प्रॉपर इंडेंटेशन किया है। आप हर एक चीज देखेंगे ट्रिपल के फॉर्मेट में ही है। देखिए यहाँ पर द मेजरमेंट 1 हैज यूनिट्स सेंटीग्रेड, अगेन इट इज ट्रिपल, measurement 1 has unit centigrade, it is one triple। So all the thing is actually shown in form of the triple in the semantic web। Okay, and this triple is actually seen like this: the measurement actually having one relation has value with the decimal। So measurement has value decimal। Okay, और ये हम क्लास के थ्रू डिफाइन करते हैं। क्लासेस हम कैसे बनाएंगे? यूजिंग आरडीएफ एंड आउल। आरडीएफएस आउल के थ्रू हम क्लासेस बनाते हैं और हम इसमें इंटर रिलेशनशिप स्टैब्लिश करते हैं। तो रियल टाइम डेटा क्या है इसका? हियर सी द measurement 1 is the real time data, or we can say the real time measurement। the measurement 1 has value, it is one relation 15। so 15 is the real time data। so all the things are that are actually of internet of things, means we are capturing the data from the internet things only na। so it is actually associated in form of triples using semantic web। so semantic web nowadays very crucial thing, all are actually applying semantic web to the IoT data। and how can we represent this RDFS classes using ontologies? So what is ontology? The ontology is nothing but the अप्लाइंग सेमेंटिक वेब क्या है? हमारी एक टेक्नोलॉजी है, सेमेंटिक वेब टेक्नोलॉजी है। देन हम सेमेंटिक वेब टेक्नोलॉजी को अप्लाई कैसे करते हैं? यूजिंग ऑन्टोलॉजी। जब हम क्लासेस बनाते हैं और क्लासेस के रिलेशनशिप बनाते हैं, सी हियर इन द प्रीवियस स्लाइड, दिस आर द क्लासेस। मेजरमेंट एक क्लास है, डेसिमल एक क्लास है, हैज वैल्यू एक प्रॉपर्टी है। हम एक प्रॉपर्टी मीन्स ये एक रिलेशनशिप बताता है। अगर हम ये बनाना चाहते हैं, बनाते हैं, देन हम ऑन्टोलॉजी का हम सेमेंटिक वेब का यूज करते हैं, सेमेंटिक वेब टेक्नोलॉजीज का यूज करते हैं और इसे ऑन्टोलॉजी बोला जाता है। सो ऑन्टोलॉजी इज नथिंग बट इट कंसिस्ट ऑफ फाइनाइट नंबर ऑफ टर्म्स। टर्म इज नोन एज क्लासेस and the interrelationship between the terms. That means, say, one measurement actually having the value. So measurement has value some value, say 45. So in form of triples. So it is nothing but the classes as well as relationship that we have seen in the earlier slide. Okay. और हम जब क्लासेस और इंटर रिलेशनशिप को पूरी तरह से बताते हैं किसी एक डोमेन के लिए, तो इट इज कॉल्ड ऑन्टोलॉजी। फॉर एग्जांपल वी कैन टेक द यूनिवर्सिटी और योर कॉलेज आल्सो। अब आपके कॉलेज में बहुत सारी चीजें हैं, बहुत सारे कंपोनेंट्स हैं, लाइक स्टाफ मेंबर्स हैं, स्टूडेंट है, देयर आर सो मेनी कोर्सेज। देन हम अगर इन सब चीजों को क्लासेस के थ्रू और प्रॉपर्टीज के थ्रू अगर डिपिक्ट करते हैं, वी शो ऑल दिस थिंग्स इन फॉर्म ऑफ द classes and property, it is known as ontology. Okay, for example, students taught by some teacher, student taught by some teacher. So say some student named XYZ taught by some teacher ABC. So it is a one kind of triple. So जो हम स्टूडेंट बता रहे हैं और जो टीचर बता रहे हैं, हम क्लासेस के थ्रू बताएंगे और इनकी रिलेशनशिप हम प्रॉपर्टी बोलते हैं। taught by एक रिलेशनशिप हो। So using the semantic web, actually what we are doing, we are creating one ontology. Okay, and here we can see the uh, all the ontologies that are right now on the web or internet. So here we can see each and every circle is one ontology which are interrelated with each other, and different kind of colors actually showing the different domains. Like green color of domain, green color actually showing the domain geography, orange color government. So these are the ontologies that are in the internet, and it is fastly growing. It is growing because of everyone actually creating their own ontology and exposing to the web. So we can have lots of ontology in order to create our own IoT application using semantic web. So already existing ontology को लेकर हम अपने web application बना सकते हैं, IoT application बना सकते हैं. So this is all about the semantic web technologies, and it is very emerging technologies. हम इस पर इस जो सेमेंटिक वेब के थ्रू जो डेटा आ रहा है उस पर हम स्पार्कल टाइप की क्वेरी भी अप्लाई कर सकते हैं. हमें कोई स्पेशल काइंड ऑफ की अदर टेक्नोलॉजी की जरूरत नहीं है. सो इट इज सेल्फ सफिशिएंट. एंड हमने ये डायग्राम पहले भी देखा है. अब इस डायग्राम में द थिंग इज दैट द डिफरेंस इज दैट आई एक्चुअली अप्लाइड सम मोर थिंग्स. लाइक हियर वी कैन सी इन द कोऑर्डिनेटर इन द रास्पबेरी पाई मैंने यहाँ ऑन्टोलॉजीज यूज की है. ओके. और जो हमने पहले एक्सएमएल डेटा देखा था, हमने उस एक्सएमएल डेटा फॉर्मेट में डेटा का एनोटेशन किया है, डेटा मॉडलिंग की है. डेटा मॉडलिंग का मतलब ये होता है हमने डेटा को लिया डिफरेंट काइंड ऑफ डिवाइसेस से और उस डेटा को रिप्रेजेंट किया एक्सएमएल फॉर्मेट में. अब हम रॉ डेटा नहीं भेज रहे हैं, वी आर एक्चुअली सेंडिंग द स्मार्ट डेटा टू whom? टू क्लाउड. ओके, some time of cloud. And for semantic web, the Focusy server is there. Using the Focusy server, we can store this data as well as we can extract the knowledge from this data. Okay, using the Sparkle and other things. And here I'm showing you some sensor annotated data. It is sensor annotated data. Here you can see these are the data. Okay, 26 one data. and uh, 297 is geographic information, means longitude and latitude. So these are the data. हम इस data को किस format में दिखा रहे हैं? हम XML, it is the turtle format. I have told you earlier that there are several formats available. So the turtle is one of the best format. That's why actually I'm showing the data in that format. But आप XML के through भी use कर सकते हैं. So ये हम जो data, ये code नहीं है, ये जो data है, इसको हमने दूसरे डेटा फॉर्मेट में दिखाया है, और इस डेटा फॉर्मेट के थ्रू हम डेटा को दूसरे डिवाइसेस में भेज सकते हैं और वो डेटा को इंटरप्रेट कर सकती है यूजिंग सम टाइप ऑफ स्पार्कल लैंग्वेज। ओके, और ये सब डेटा कनेक्टेड है एक दूसरे से। ओके, हम आपने लिंक डेटा का नाम सुना होगा। लिंक डेटा मींस व्हाट? इफ वी आर अप्लाइंग the semantic web technology to the data, it becomes linked data only, यानी कि एक डेटा दूसरे डेटा से लिंक्ड है। सो आप यहाँ देख सकते हैं, यहाँ M3 लिखा हुआ है, M3 has value, and this M3 is nothing but one class, and this class is defined in some ontology, and ontology is described in some URL. So all the things are linked, सभी चीजें, सभी क्लासेस, प्रॉपर्टीज एक दूसरे से लिंक्ड है, and that's why it is known as the linked data using the semantic web. And आप यहाँ स्पार्कल क्वेरी भी देख सकते हैं। इट इज अ काइंड ऑफ स्पार्कल क्वेरी। ओके, सो हम स्पार्कल क्वेरी के थ्रू डेटाबेस ट्रैक कर सकते हैं, और इसके लिए हमें कहीं डेटा को स्टोर करने की जरूरत नहीं है। ऑन द गो, इफ द डेटा इज स्ट्रीमिंग, वी कैन extract the knowledge from it. So the Sparkle is on the go query language. Okay, and it is very promising, and it actually takes very less time. और OKC सर्वर में हम इसे स्टोर भी कर सकते हैं। The data is same when we are storing this data from coordinator to OKC server. Means it is nothing but the cloud architecture. हम अब क्या कर रहे हैं? WSN के डेटा को क्लाउड में भेज रहे हैं। So Internet of Things means all the technology together, either cloud, WSN, semantic web, hardware part, all the things together. So it is all about your Internet of Things and semantic web. If you are having any queries, so you can ask me. Thank you very much for having me. Any queries, you can ask me.
Thank you, sir, for the very informative session. I hope participants have enjoyed it. If they are having any queries, you can directly ask to our resource person. He is waiting for your queries. If you are having some on the basis of today's topic, what sir has delivered on IoT architecture, semantic web, data model. So first of all, I would like to invite all the participants, if they are having any queries, they can ask to our resource person, Dr. Rajnandgaon sir.
आपके कोई से भी डाउट होंगे, और आप हिंदी में या इंग्लिश में किसी में भी पूछ सकते हैं। द थिंग इज दैट, मेन थिंग इज दैट कि आपके क्वेरीज क्लियर होने चाहिए। और आजकल नाउअडेज ये बहुत ट्रेंडिंग चीजें हैं, लाइक इंटरनेट ऑफ थिंग्स, सेमेंटिक वेब, क्लाउड। तो आप अगर इसमें कैरियर बनाना चाहते हैं आगे, अगर कुछ ज़्यादा अच्छा करना चाहते हैं आगे, सो यू कैन आस्क मी द क्वेश्चन। और आप मेरे ईमेल आईडी भी सर से ले सकते हैं, आपको मेरी ईमेल आईडी दे देंगे। बट अगर आपके पास कोई भी क्वेश्चन हो तो आप पूछ सकते हैं, छोटे से छोटे, बड़े से बड़े क्वेश्चन, कुछ भी।
Sir,
Yes.
Sir, what is the Sparkle language?
sir, my name is Tejeshwari Thakur. Sir, I have one question. Sir, IoT के सिक्योरिटी और प्राइवेसी के बारे में सर कुछ बताइए। तो जैसे हम सिक्योरिटी पर्पस से अगर काम करना चाह रहे हैं तो IoT के हमको मेन सिक्योरिटी पर्पस पे फोकस करना है, तो हम सर किस एरिया पे मेन फोकस करें?
देखिए, IoT में जो हमने जो काम किया था वो डेटा मॉडलिंग पे काम किया था स्पेशली, बट सिक्योरिटी एक मेन इशू है, और सिक्योरिटी को हमें साथ में रखकर चलना होगा। देखिए, मैंने आपको बताया था, स्लाइड आपको दिख रही होगी, जब आप डेटा भेजते हैं, जैसे 8 सेंसर नोड्स है, ओके, इससे हम डेटा हम कोऑर्डिनेटर पे भेज रहे हैं या कोऑर्डिनेटर से डेटा हम सर्वर पर भेज रहे हैं। एट बोथ द एंड्स, बोथ द टाइम्स वी नीड सिक्योरिटी। अगर हमारी डेटा एनक्रिप्टेड नहीं रहेगा, देन
जी जी
कोई भी उस डेटा को क्या कर सकता है, एनकोड कर सकता है, इवन कुछ स्पैम्स और कुछ malicious. And nowadays, blockchain technology is there. Okay, just write it. Blockchain technologies.
या
So
आई नो
blockchain.
सर.
Yes. Okay. Good. Very good. So blockchain technology is there. Using that technology, you can actually encrypt your data. और
जी
IoT में आपकी सिक्योरिटी में एक बड़ा चैलेंज ये है कि आप सिक्योरिटी सिंपली कहीं भी लगा सकते हैं। लाइक अगर बहुत ऐसे डिवाइसेस है जो माइक्रो प्रोसेसर है, तो आप इजीली सिक्योरिटी लगा सकते हैं। पर जो रिसोर्स कंस्ट्रेंट डिवाइसेस होते हैं, रिसोर्स कंस्ट्रेंट डिवाइसेस मतलब जब जिसके पास ज्यादा रिसोर्स कैपेबिलिटीज नहीं रहती है, लाइक आर्डिनो उनो जो कि बहुत कम बैंडविड्थ पे काम करते हैं, तो उस पे हम कैसे अप्लाई करें सिक्योरिटी को, ये नया चैलेंज है। तो उस
जी
पे हमें जो प्रोटोकॉल्स है और जो हमारे एल्गोरिदम्स होंगे ऐसे होने चाहिए सो दैट वो रिसोर्स कंस्ट्रेंट डिवाइसेस या फिर मैं बोलूँ माइक्रो कंट्रोलर्स पे काम करने चाहिए। सो एक बड़ा चैलेंजिंग इशू है और इसके साथ हमें यहाँ अप्लाई भी करना है, और अप्लाई करने के साथ साथ हमें ये भी देखना है कि डेटा सिक्योर रहे, क्योंकि ये डिवाइसेस बिल्कुल कंप्यूटेशनल पावर को सपोर्ट नहीं करते, बहुत लेस कंप्यूटेशनल पावर रहते हैं। तो हमें ये भी देखना है कि भैया डेटा ब्रीच ना हो। ओके, तो आप ब्लॉकचेन टेक्नोलॉजी की तरफ जा सकते हैं, एंड देन
जी
डेटा सिक्योरिटी इज वेरी इंपॉर्टेंट इशू।
जी थैंक यू.
Any other questions you can ask me?
Good afternoon, sir. My name is Chandrasekhar. I have one question. What is mesh topology?
Mesh topology, no? So actually, there are several topologies. Just see this. See this diagram. See this slide. Mesh topology means that first of all we must know about the topologies. What is the topology? If we wanted to actually interact different kind of devices, okay, wire or wirelessly, यानी एक डिवाइस को हम दूसरे डिवाइस से कनेक्ट करना चाहिए, we wanted to connect one device from another device, we have to use some medium, wired or wireless. It means we can connect this type of devices through the wire, okay, tangible wire जो हम छू सकते हैं, okay, or wireless using Bluetooth or some Wi-Fi or something. Then it is nothing but the connection establishment, okay. But say there are several devices in the network, okay, not one or two devices, but the several devices. Then there are so many type of ways to connect those data. Say one device is connected with another, and another device is connected with another, and then again those devices connected with another. Okay, so it is nothing but the ways to connect the devices. So there are so many, and it is also called the topology. There are so many type of topologies, like bus topology. Bus topology means we are connecting the devices. Okay, either it is computer or WSN devices or any device. We are connecting to devices linear fashion. Means one device is connected with another, and that device is connected with another device, like linear fashion. There is one more topology called star topology. That means in the center there is one device and all the devices are directly connected with the center. Okay, it is star topology. Likewise, likewise mesh topology is there. Mesh topology means all the devices are connected with each other. It is kind of mesh. You know what is mesh? Mesh is nothing but the kind of all the dots are connected with each other. Here we can see in the slide one device. Here, say I'm taking you can see my cursor now. Just see my cursor. This device is connected with all the other devices. This device is connected with the neighbor device, this neighbor device, this device, as well as the coordinator. So this device is connected with each and every device. Okay, and likewise, all the devices are connected with each and every device. So it is called the mesh networking. That means each and every device are connected with other devices. It can be wired or wirelessly. ओके, मीन्स ये वायर के थ्रू भी हम कर सकते हैं कनेक्शन, और वायरलेस भी कर सकते हैं। ठीक है, हमने यहाँ पर क्या किया, हमने वायरलेस कनेक्शन किया है मैश नेटवर्क, और उसके लिए हमने zigbee प्रोटोकॉल यूज किया है, एक्सबी डिवाइस यूज किया है। ओके,
सर अदर टोपोलॉजी को भी इसमें यूज कर सकते हैं क्या?
जी ये डिपेंड करता है आपके एप्लीकेशन पे। देखिए मैंने आपको इसमें बताया था, जब मैं स्लाइड को बता रहा था, मैंने एग्रीकल्चर डोमेन पे काम किया। एग्रीकल्चर डोमेन में क्या होता है, हमारा कोऑर्डिनेटर से एक जो हब रहता है, या कहीं जो हमारा एग्रीकल्चर लैंड में कोई घर है उसमें रखा हुआ है, और एग्रीकल्चर लैंड हो सकता है 100 एकर्स का हो, 200 एकर्स का हो सकता है कि बहुत लंबा लंबा हो। ओके, तो अगर सबसे लास्ट डिवाइस सबसे दूर में है और वो डायरेक्टली कम्युनिकेट कर ही नहीं सकती है अपने कोऑर्डिनेटर के साथ, जिसको गेटवे भी बोलते हैं, देन कम्युनिकेट कैसे करेगी? तो वो क्या करती है, अपने नियरेस्ट डिवाइस को भेजती है, वो नियरेस्ट डिवाइस फिर अपने नियरेस्ट डिवाइस को भेजती है, ऐसे करके डेटा आपका कोऑर्डिनेटर के पास आता है, कोऑर्डिनेटर के पास आता है। ओके, जो डेटा है आपका कोऑर्डिनेटर के पास आता है। अब से आपके पास ऐसा कोई सिनारियो है जहां पर आपका हब सेंटर में, लाइक समझ लो एक आपका फार्म हाउस है, और जिसमें घर जो है सेंटर में बना हुआ है और खेत आजू बाजू है। ओके, आपका कोऑर्डिनेटर आपने हब में रख दिया या फिर सेंटर में रख दिया, और आप स्टार टोपोलॉजी यूज करो, नो प्रॉब्लम। इट डिपेंड्स ऑन द एप्लीकेशन कि कौन सी टोपोलॉजी यूज करनी है। ओके, आप स्टार भी यूज कर सकते हो, आप बस यूज कर सकते हो, आप हाइब्रिड यूज कर सकते हो, आप जो टोपोलॉजी चाहे वो यूज कर सकते हो। ये डिपेंड करता है सिचुएशन पर।
यस सर, थैंक यू सर।
ओके, एनी मोर क्वेश्चंस?
Sir,
गुड आफ्टरनून सर।
हाँ, यस यस।
आई एम प्रिया श्रीवास्तव। सर मेरी क्वेरीज ये है कि नेटवर्क सेक्टर में, नेटवर्क फील्ड में हम बीएससी कंप्यूटर साइंस, एमएससी कंप्यूटर साइंस के स्टूडेंट्स होते हैं, वो किस किस जॉब्स में अप्लाई कर सकते हैं और क्या के थ्रू कर सकते हैं अप्लाई?
फर्स्ट ऑफ ऑल देखिए, सीएससी जो है कंप्यूटर साइंस एंड इंजीनियरिंग अभी बूम पे है। अभी सबसे ज्यादा कोई जॉब देने वाला सेक्टर है तो वो कंप्यूटर साइंस एंड इंजीनियरिंग है, इवन प्राइवेट में और गवर्नमेंट में। सो
Yes, sir.
और बहुत, और क्यों है ऐसा? क्योंकि बहुत सारे स्टूडेंट्स इससे जुड़ रहे हैं, बहुत सारे टेक्नोलॉजी इससे जुड़ रहे हैं, बहुत सारे कंपनीज इससे जुड़ रही है। सो आपको इसके लिए, जैसा मुझे लगता है, अगर इंडस्ट्री में जाना है तो आप किसी एक टेक्नोलॉजी को लीजिए और उसको, रिसेंट टेक्नोलॉजी जो है उस पर हैंड्स ऑन कीजिए, उसको बहुत अच्छे से सीखिए। लाइक पाइथन आप सीख सकते हैं, ओके, और पाइथन के अलावा जावा भी सीख सकते हैं, या बहुत सारे लैंग्वेज। आजकल पाइथन बहुत डिमांडिंग है, तो आप पाइथन सीख सकते हैं। और सिर्फ यहीं तक लिमिटेड मत लिख रखिए कि आपने पाइथन सीख लिया देन हो गया, मैंने सीख लिया। उसको कहीं अप्लाई भी कीजिए। दैट मीन्स आपने पाइथन सीखने के बाद उसको समझ लीजिए आपको इमेज प्रोसेसिंग पसंद है, तो फिर आप क्या कीजिए, इसको न्यूरल नेटवर्क्स में यूज कीजिए। आपको आईओटी पसंद है, पाइथन को आईओटी में यूज कीजिए। आपको कोई और फील्ड पसंद है, उसको अप्लाई कीजिए। ओके, और आप लोग कोशिश कीजिए कि एनपीटेल से सर्टिफिकेट मिल पाए आपको। ये कोर्सेज कीजिए, एनपीटेल से सर्टिफिकेट लीजिए, या फिर बहुत सारे प्रोफेशनल कोर्सेज होते हैं, उडेमी में होते हैं, बहुत सारे वेबसाइट्स हैं, बहुत सारे AWS के सर्वर्स होते हैं, आपके गूगल के भी सर्वर्स होते हैं, उनके सर्टिफिकेशन कोर्स कीजिए, वहाँ से सर्टिफिकेट लीजिए। तो ये बेनिफिट होगा आपके लिए कि आप लोग कहीं पर भी जॉब के लिए जाते हैं, आइदर इन कंपनीज और कहीं पर भी, या टीचिंग के लिए जाते हैं या एमएसएस के लिए जाते हैं, ये सर्टिफिकेट देके जाते हैं, और उस सर्टिफिकेट से आपका वेटेज बढ़ता है। ओके, तो एकेडमिक चीज़ों के साथ साथ आप एक्स्ट्रा चीज़ें भी करते हैं, कुछ टेक्नोलॉजीज में हैंड्स ऑन करना, उसको कोई कहीं पर अप्लाई करना, तो ये बहुत ज़्यादा बेनिफिशियल होगा आपको। थैंक यू।
थैंक यू सर।
हाँ, अच्छी और कोई क्वेरीज है आप लोगों की?
good afternoon, sir. Myself Umesh Sahu, and my question is, how is the semantic web is different from the normal web?
Okay, actually the normal way is means you have seen the web pages are there. Okay, in order to represent the web pages, what we use HTML kind of programming. Okay, And nowadays, CSS and so many other fancy things like JavaScripts are there that are actually participating in order to show your web pages. The semantic web is the advanced type of web. Okay, it is not the HTML or CSS or we can say that JSS. Okay, it is an advancement of the web. Okay, and in the HTML, it actually gives the data only with the data format. But here we are using the data. First of all, the data. Second is the data format, and the third one, the meaning to the data. Earlier, it was not there. Means meaning was not there. Here we are providing the meaning using ontologies and semantic web technologies. So it is very different. It is, we can say, the future World Wide Web, the Web 3.0. We are providing meaning to the data. Okay, and all the data are connected. Not only the files, means one HTML file is connected with other files using hyperlink. We can means go to the different pages. But here, not the pages, not the resources, but all the data are connected. That I have shown you in the code part, that data modeling part. Okay, so it is advanced web. Thank you.
Thank you, sir.
Any other queries?
Yes, sir.
Yes, please.
So first of all, I would like to thank you for your valuable time and efforts you are giving us.
Thank
So
you.
my question is about the one of the challenges we face, data volume. As you have said, sir, IoT devices produce lots amount of data, and it
Tremendous
is,
amount of data.
yeah,
Yes,
and it is expected that it will grow tremendously in the upcoming years.
yes, right.
And this data needs storing, transmitting, and processing it is significantly a major challenge, sir. So
Right.
how do we cope up with this challenge, sir?
So the data means having the large amount of data is always the issue. Yes, definitely. How can we process this data? But the solutions are coming in form of cloud also. You can see there are lots of servers. Even you can use lots of server in free of cost. Like AWS server is there, and some Google server. Actually, I forgot the name of that Google server. There are so many cloud technologies. So like data is emerging means the data is means uh, what should I say? We actually having the lots of data. Okay, likewise, we are having lots of clouds nowadays. Okay, the cloud technology is also growing, so we can manage those data using the cloud technologies and using the different type of other technologies like semantic web is there. Na? Okay, so cloud is the solution. Thank you. Any other
Okay,
question?
sir. Thank you for your valuable knowledge and expertise.
Thank you very much. Any other question?
Thank you. Thank you so much, Dr. Girdhar sir, for the very informative session. And it was pleasure to have you. You have also answered all the queries of our participants. They are eagerly waiting for this session of IoT. Let me inform you one thing, sir. Our college students have worked on Arduino and they have just developed a model, sensor-based model. What you are talking about in your presentation, they have worked on sensor-based model and many other sorry, many other models of our college. I have just started to work on Arduino software, as you have suggested, as they are cheap as comparison to Raspberry. They are working on it, and we have presented one water purifier system, temperature-based sensor model. So two to three models based on IoT they are working. That's why it is very informative session for all our students. And thank you so much for your valuable time. You have accepted our notice and request in short period of time and serve giving a service to our college. Hope again we will meet in future. Now I would like to request Mrs. Hem Pushpa, HOD Computer Application, to present vote of thanks. So please, ma'am.
धन्यवाद राघव सर। आज नेशनल वेबिनार के दूसरे चरण में आप सभी ने हमारे वक्ता डॉक्टर गिरधर उरपुरे, असिस्टेंट प्रोफेसर और R&D एसोसिएट, यूनिवर्सिटी ऑफ साइंस एंड टेक्नोलॉजी हैदराबाद को सुना। सर, आपका व्याख्यान IoT एंड वेब सेमेंटिक्स पर था, जिसको आपने प्रतिभागियों तक बहुत ही सरल एवं सहज तरीके से पहुंचाया। हम जानते हैं कि आज के टेक्नोलॉजी युग में आईओटी का बहुत बड़ा ही योगदान है और मैं हिमपुष्प का कंप्यूटर साइंस एंड एप्लीकेशन विभाग की तरफ से आपका धन्यवाद ज्ञापन करना चाहती हूँ। जिस तरह आपने आईओटी के महत्व को समझाया, मैं आशा करती हूँ कि सभी प्रतिभागी आईओटी के महत्व को अपने दैनिक जीवन में लेकर आएंगे और कंप्यूटर साइंस एवं एप्लीकेशन विभाग की तरफ से समस्त प्रतिभागियों का भी धन्यवाद ज्ञापित करती हूँ। आपकी उपस्थिति के कारण यह व्याख्यान जीवन आकर्षक व शिक्षाप्रद बन पाया। अंत में पुनः मैं हमारे वक्ता को धन्यवाद देती हूँ कि उन्होंने अपने बहुमूल्य समय में से कुछ समय हमें दिया। धन्यवाद सर। आज के नेशनल वेबिनार की समाप्ति की घोषणा करती हूँ। धन्यवाद।
Thank you all for having me. Thank you. It's a great honor to have you.
Thank you, sir. Thank you so much. Feedback link will be shared in the WhatsApp group and to the personal email IDs. So please fill the feedback form for today's session. Thank you. Thank you so much, sir. Thank you. Thank you all the participants for giving your valuable time. Thank you.
Thank you. Thank you all.
Thank you, sir.
4 ही मेल है सर उसमें, वो वाले में ये रिफ्रेश करें। ये वाला ना एकदम बढ़िया रिस्पॉन्स करता है। यही तो मेल आई डी ना, दिग्विजय 19। यस सर, दिग्विजय कॉलेज वाले किससे दिग्विजय कॉलेज 19 अब देख, दिग्विजय वाले नहीं देख, मेरे से नहीं जा पा रहा है क्या? मेरे से साइन दिखा रहा है। अपना व्हाट्सअप चालू कर, तो उसमें वहाँ से उठा, यहाँ से चल। चांस लोग घर बिठाने पर आप
क्या हुआ दादा?
उस पर आया होगा, ठीक है, ग्रुप पे उसको कॉपी करो, चैट बॉक्स में डाल दो। हाँ, यूट्यूब पे। और पर्सनली सब मेल कर दी? हाँ, मेल कर दिए। थैंक यू सर, आपको बताइए सर। हाँ, ये वाला सर? हाँ, नहीं नहीं, बैठ कर ये वाला? हाँ, नेटवर्क, ये वाला है सर? हाँ। नहीं सर, वो सर ना वाईफाई से कनेक्ट किए थे लैपटॉप को,
वाला
इसलिए।
जो छोटा वाला था सर, वो उसमें वाईफाई से कनेक्टेड था।
फिर दूसरे
वाईफाई का रेंज नहीं, यहाँ मेरे को लगा है दूर हो जाएगा।
नहीं सर, वो केबल फाइबर का रहता ही है काम चैट पे, उसमें या यूट्यूब पर ये खोल। हाँ, स्विमिंग खोल, वहाँ पेस्ट कर दे।
पहले दिन तो कम अटका था, आज ज़्यादा अटका है।
यहाँ ऑप्शन है
नहीं, आपका डेटा खत्म हो जाएगा।
उसमें उसमें
आज ना?
इसमें इसमें क्या, पहले इसमें
आखिरी बार
इसमें जा, चैट में डाल कर, मीट के चैट में डाल, मीट के चैट में।
मीट तो इसमें है ना, क्रोम खोल।
तो इस वाले में है सर। हाँ, इस वाले में है, यहाँ डाल, यहाँ डाल,
कॉपी कर।
हाँ, इंटर कर और डाल। वो लैपटॉप लगाया सर, फिर अच्छा हुआ। हाँ, अब उसमें उसका चैट कहाँ है? कल जैसे खत्म हुआ लाइव चैट, यहाँ डाल, इंटर कर और डाल इतना। सर कल कैमरा लगाएंगे, कल कैमरा लगाएंगे, मेरे पास रखा है अभी। लैपटॉप से मतलब वेब कैम को यूज़ करेंगे कैमरा पर। यहाँ एंड करना, ठीक है, एंड कर, ठीक है, फिर उसमें जा,